Hey, what's going on, guys? Mr. Flores here, and this is a video dealing with slope and rate of change, and it really is one of the things kids hate for some reason in mathematics. I'm not sure why, but it's one of the most widely used types of questions on standardized tests. The Park really liked it, and in reality, it's really not that hard of a concept. So before we get into like mathematically thinking about slope, I'm just gonna I don't know. I'm not an artist, so just hang out my picture. So if we look here, we have a fort here, and there's a pot of gold on top. Of course, we want to get to the gold, and we're a little guy down here. This is us, okay? We have a smiley face because we're going to get the gold. All right, but in order to get to the gold, we have to build a ramp that's going to go straight up, okay? We can't have a curve. We're not having loops. It's just going to go straight from the ground directly to this point right here, all right? So if I start all the way over here and I build our ramp, all right, if we walk at the same speed up the ramp, it's going to take a while to get there. Because if you notice, this is a very, very long ramp, okay? The rate of change in which we're getting to the gold is not going to be very big. It's kind of going to be a low number, okay? Because it takes a long time to get from the ground up to the gold. But let's say that we've been working out our calves, so we have really, really strong calves. So we can now start here, all right? We can start here. Actually, if you notice this, this second ramp we built is a little more steep, okay? The slope, if you want to say, is greater because it's more steep. If we fell, we would roll down faster, okay? The amount of time it takes to get from the ground to the top is a lot quicker, all right? It has a higher rate of change because every time we walk up, we're actually going further, whereas when we walk up this one, we don't go as far this way, right? But let's say we have this magical blue ramp that is almost straight up and down. That's supposed to be straight, okay? This means we have really, really strong calves because we can walk almost straight up, or maybe we're Spider-Man. But if we notice, the amount of time, as long as we go at the same speed, okay, the amount of time it takes us to get up the blue ramp is going to be the quickest, is going to be the shortest time because it's the quickest or shortest distance from here to here. The rate of change as we go up is a lot greater because we're just going higher, faster. All right. So this is the slowest rate of change, medium rate of change, and a high rate of change. If we wanted to give these number values, just so we can think of like speed-wise, this would be maybe a 2. This would be like a 4. This would be, we'll say, an 8, all right? Because if you notice, as it gets steeper, the slope gets greater, the rate of change increases, all right? And as long as you understand this idea, you understand slope. A lot of kids think they don't, but they really do. A lot of different things that could be a rate of change in real life is, if you think about it, when you're driving a car, miles per hour, that's a rate of change because every hour you're going to be going a certain amount of miles. The amount of money you make at your job, if you're making $8 an hour or you're making $1,000 every 2 weeks, that's a slope. That's a rate of change. You can visually see your money increase, and you can plan in a X amount of hours or X amount of weeks how much money you're going to have because it's a constant rate of change. And that's the other thing with slope. It's constant. This line, since it technically is straight, it's never going to change depending on where on the line you are. It's still going to be a rate of 8 if you want to look at it that way. But as long as you can understand this basic idea, basic concept, you understand slope. What we're going to do now is we're just going to turn it into a little bit of math. All right, guys, now to talk about slope in a mathematical terminology. All right, so to get into that, we're going to talk about our friend Bob, and we're going to talk about Skittles, because everyone loves Skittles, especially me. So we know that our friend Bob has 50 Skittles, and every 3 minutes he eats 5. Right? So in reality, he starts with 50. Every 3 minutes, he's going to be eating 5. So sooner or later, he's going to run out of Skittles. All right? So let's just kind of plot this scenario in a graph, in a table, which we've done before. So let's say at 0 minutes, how many Skittles he has? Well, at 0, he had 50. Then after 3 minutes, he has 5 less because he eats 5 every 3 minutes, so he'll be at 45. Then in 6 minutes, well, he ate 5 the first time, so then in the next 3 minutes he'll eat another 5, so he'll eat a total of 10, so it'll be 40. In 9 minutes, he ate 15. So 50 minus 15 is 35. Okay? Basically, what we want to do is we want to kind of find out what is the slope or the rate of change in this situation. All right? And the rate of change is going to be Skittles per minute. Okay? So basically, like I said before, slope is a constant rate of change, meaning that it stays the same the entire time. So let's just see every time if our Skittles are constantly dropping at the same rate. Well, we had 50 and it went down to 45, so that's minus 5. 45 to 40 is, again, minus 5. 40 to 35, again, is minus 5. So at least the rate in which our Skittles are changing is constant, which is good. So that means that we may have a slope. Now we got to go over and look at our, we want to go and look at the minutes from our table. Okay, so if we look, we started at 0 and we went to 3, so that's an increase of 3. Then he went from 3 to 6, which again is an increase of 3. Then he went from 6 minutes to 9 minutes, which is also an increase of 3. So since we look at our table, every interval of the minutes is the same, it's an increase of 3, and every interval of Skittles is a decrease in 5. Okay, which that should make sense because in the scenario it said he ate 5 Skittles every 3 minutes. And like I said, we're talking about a rate of change. We're talking about the Skittles per minute. Okay. Now, if you guys remember when we did proportions, the word per just kind of implies a fraction. So, really, it's Skittles over minutes. Okay, and we're talking about the change, the way our Skittles are changing compared to the minutes. So, our Skittles every interval are dropping by 5. Okay, and the amount of minutes that they're dropping by 5 is 3. So our slope in this scenario is negative 5 over 3, because every 3 minutes he's losing 5. Okay. Again, what we can go back to now is we can think of slope as just a pure mathematical concept. If we think about it, our minutes is our dependent variable, which is our x. Our Skittles is the minutes is the independent variable. The Skittles is dependent, so that's a y. So in reality, we can think of slope as the change in y over change in x. Okay, that's all that slope is in a nutshell. It's the change in y over change in x. Yes, when we talk about certain scenarios, it can change, but in reality, it's just the change in y over the change in x. Okay, so let's say we have a table here. We have an x and a y. Let's say we have negative 5, negative 1, I don't want negative, I want it to be positive 3, and then 7. All right, now let's say our y's go from 22 to 8. No, I don't want 8. I'm at 18. So then it goes to 14, then it goes to 10. All right. We need to find out, does this table represent a linear equation, aka does it have a slope? So if we want to make sure it has a slope, we must check to make sure that every increase in y is the same and every increase or decrease in x is the same. So negative 5 to negative 1 is positive 4. Negative 1 to 3 is positive 4. Positive 3 to 7 is a positive 4. 22 to 18 is a negative 4. 18 to 14 is a negative 4. 14 to 10 is a negative 4. So both every y change is the same, every x change is the same. Therefore, we can conclude that this has a slope, at least for this interval. And the slope is going to be denoted as the change in y over the change in x, or negative 4 over 4 is just a negative 1. All right, guys, now we're going to look at slope from a graphical representation, okay? So basically, what you want to do is you want to be able to find the slope between 2 points, all right? And this whole idea of being able to do that really helps you out later on when we're graphing, especially on that project we're going to do with Desmos where you make your own picture. It's going to be very, very useful and important, all right? But for now, if we go back to what slope is just your change in y over change in x, right? We found that out when we were talking about Bob and his Skittles. So it's change in y over change in x. When you're talking about slope, a lot of times the lowercase variable of m denotes that you're talking about slope. It comes from an equation we're going to use to graph later on. But just take my word for it that m generally signifies you're talking about a slope. All right. So I have a blue point here and I have a red point here. So basically, the coordinate of the blue point is 1, 2, 3, negative 3, comma 3. All right. And the red dot is positive 1, comma 1, 2, 3, 4, 5. All right. So again, the blue point is negative 3, or negative 3, comma 3. The red point is 1, comma 5. All right. Now, in order to find the slope, we just need the change in y over change in x. Okay. Now, if we think mathematically, what does the word change mean? It kind of means what's the difference, or what's the difference or change from one to the other. So that really implies subtraction. All right. So what we're going to do here is we're going to find the difference or the change in the y variables, and then the difference and the change in the x's, and set them over each other. So if we notice the y variable is 5, we want to know the change in y. So it went from 5 to 3. So it's going to be 5 minus 3. And then the thing you have to do is whatever point you started with. For instance, I started with the red point for the y's and subtracted the blue point. You must start with the red point of the x's and subtract the x point of the blue, all right? Because the order has to stay the same. So if we look here, it's going to be 5 times 3 is 2. Then 1 plus 3, because it was 1 minus negative 3, is 4. All right, and you're going to get 1 over 4. All right, so the slope between this point and this point is positive 1/4. All right. Oh no, that's not 1/4. Sorry, 2 over 4 is really 1/2. All right, and now if we were to draw our line, it's going to look very, very nice. I'll go through there like that, and that's our line that goes through the 2 points. All right. What I want you guys to do is pay special close attention to this line right here. Look how it's going. If we're looking from left to right, it's going up. Okay, that's going to help us in a little bit. All right. So what I want us to do now is we're going to look at another graph. All right. And again, we're just going to find the slope between 2 points. So we're going to have we'll have a red point, I'll put a red point right here, which is negative 2, 1, 2, 3, 4, 5, 6, 7. So this is negative 2, comma 7. And then I'll put our blue point, let's say down here, which is at 1, comma 2. All right, now we want to find the slope. We want to find the m. All right, so again, it's the change in y over change in x. So our y went from 7 to 2, so it's 7 minus 2. And then it went from the x went from negative 2 minus 1 because it went from negative 2 to 1. So it's 7 minus 2 is your change in y. Negative 2 minus 1 is your change in x. When you simplify, you get 5 over negative 3. Or to simplify, it's negative 5/3. All right? And again, I'm going to draw our line. Going through that point, going through there, and we're good. All right? But again, look at this line from left to right. If we were to put a little guy up top here, he wouldn't be able to stay. Let's say let's say he's up here. If you go left to right, he's going to be falling, okay? And look at our slope. It's a negative 5/3. Now, if you look at this line going from left to right, our little guy would be walking up it, and our slope is a positive 1/2. All right? What I want you guys to do is I want you to think about what's the correlation between this line falling and the slope being the type of number it is, then this line increasing and the slope being the type of number it is. All right? All right, so like I said, think about the relationship between what the graph looks like and the type of number the slope is. Again, what is the graphic like? What the type of number the slope is. When everyone's done watching the video, I'm going to go over some more little tidbits, and we'll get to there. So hopefully you enjoyed it, and watch the next video to learn the rest of the tidbits.